10 things we still don't know about space. Number 10. The origins of the moon. Isn't it strange how we're getting mentally ready to colonize Mars, but scientists are still unsure of how the moon formed? Well, it's not like they have no clue. There are a few hypotheses out there, but none of them can be taken as 100% accurate. So the debate is open, and new studies keep coming, presenting different contrasting scenarios. The most accredited theory is that the moon was formed after a Mars-sized body collided with Earth several billion years ago. But here's the problem with that theory. If this was true, the moon should share its structure with the impactor rather than from Earth. However, according to the lunar samples we've been collecting for decades now, the satellite's composition is very much similar to Earth, which is why in 2017, Israeli researchers Raluca Rufu, Oded Harrison, and Haggai Paretz proposed instead that the moon came from a dozen of Earth's lesser impacts with objects ranging from 1% to 10% of its mass. This would basically make the moon an orbiting orb of debris. Still, no matter how interesting this is, it remains a theory, and so the mystery carries on. Number 9. Why the universe exists. Have you ever wondered why you, or humankind in general, or why not the entire universe, exist? If so, you're not alone. First of all, because, according to psychology, questioning your existence happens to everyone sooner or later. And second, there are scientists who are actually working on the matter, you'll get that joke in a second, trying to give a definitive answer. All we know so far is that the whole universe started with an explosion. Basic, right? We learned that at school. However, that's a very simplified version. According to the standard model, the explosion happens with the clash of equal amounts of matter and antimatter. What the antimatter is a mystery in itself, but to simplify, let's say it refers to subatomic particles that have properties opposite to normal subatomic particles, i.e. the matter. Theoretically, an equal amount of matter and antimatter would annihilate each other, pushing us towards nothingness. Which makes no sense because we exist, and the universe exists. So how is it possible? That's exactly what researchers have been trying to find out. The answer is still unknown, but they're working on it. Number 8. Does the multiverse exist? If you can cope with the fact that our whole existence literally makes no sense, now ask yourself another less existential question. We've established that our universe exists, but does the multiverse exist too? The multiverse is a cosmos in which there are multiple, infinite universes, and according to recent studies, it's a plausible option. In 2017, the UK's Royal Astronomical Society published a paper on the so-called cold spot, a cool patch of space seen in the radiation produced by the formation of the universe more than 13 billion years ago. The spot has been puzzling astronomers and cosmologists for years. The hypothesis of the research is that the cold spot is an optical illusion produced by a lack of intervening galaxies, and perhaps it was caused by a collision between our universe and a parallel one. Now, if you put it like that, the cold spot should be taken as proof of the existence of the multiverse. However, nothing is certain, and one single hypothesis isn't enough, according to the scientific method. Which is why many among the scientific community, including Paul Steinhardt, one of the original architects of the multiverse theory, are still skeptical about it. Number 7. Where is Planet 9? Pluto has not been a part of the 9 planets of the solar system since 2006. However, researchers worldwide are in pursuit of a missing Planet 9. But why are they so sure there's a 9th planet? It's a good question. The truth is, they're not 100% sure, but the presence of a 9th planet would actually explain the orbital trajectories of out there celestial bodies. Let's take, for example, Sedna, a planetoid discovered in 2003. Sedna has roughly half the diameter of Pluto and is located about 85 astronomical units from the Sun, about 3 times as far as Neptune. In 11,000 years, the dwarf planet has swung from 76 astronomical units to over 900 and then back again. Which adds a further question. How can such a massive object reach an extended orbit without getting completely ejected from the solar system altogether? The most likely answer is there's a massive gravitational body out there, let's say Planet 9, pulling things out of whack. But if so, how come we can't find such a massive planet? One reason could be we don't have the telescopic technology to detect it yet. Number 6. The Fermi Paradox. The problem here is it's not like we know what the Fermi Paradox is, but rather we can't seem to overcome it. What is the Fermi Paradox? Well, let me put it this way. It's highly probable that across the whole universe, or multiverse, we're not alone. If that's the case, then why haven't we heard from any other form of life? This is the Fermi Paradox, which takes the name after physicist Enrico Fermi, who first posed the question in 1950. Since then, scientists have been working on the answer. Some believe that the silence is the product of the Great Filter, an evolutionary wall impermeable to most life. This means that we're not receiving communication because we're either the most or least advanced civilization. Others, such as SETI, the Search for Extraterrestrial Intelligence, suggest that most of the universe is colonized and communicating, but we are stuck in a desolate area. A bit like when you visit your grandma out in the countryside and there's no reception on your cell phone. However, the most supported theory is that if others are out there transmitting signals, we're just probably listening to it wrong, like we don't have the right technology or understanding of the universe yet. Number 5. The Big Crunch. You may have guessed by the name that the Big Crunch theory has something to do with the Big Bang. We can say the Big Crunch is based on a specular process. As everything started, so should it end, with a massive explosion. According to the theory, all the mass in the universe will eventually give way to gravity and be drawn together into a smaller space, then merge into a dense and hot point and ultimately get wiped out. How fun. Still, not all experts are on board with this theory. In fact, some argue such a hypothesis doesn't quite make sense with what we currently know about history, especially in regards to ongoing studies and discoveries on dark energy. According to some in the scientific community, over the past few billion years, dark energy has kept pushing the universe outwards. Therefore, if the universe keeps expanding, how exactly would it collapse in on itself? It's a fair point. Still, we can't rule the theory out, because just like how we don't know how the Big Bang started yet, we might still find the answer after all. Number 4. Mysterious radio signals. Remember, one of the answers to the Fermi paradox could be we're unable to understand the signals we receive? Well, that's exactly what could be happening right now. Last February, the scientific community revealed that an object 500 million light years away appeared to be transmitting signals every 16 days. The discovery has been made while in the process of the collaboration of two types of research, the Canadian Hydrogen Intensity Mapping Experiment and the Fast Radio Burst Project. Over the course of 4 days, the signal would release a burst or two each hour. Then it would go silent, only to come back after 12 days. The signal is an FRB, Fast Radio Burst, bursts of radio waves in space that last just a millisecond. The problem? Astronomers can't figure out what causes them and why they occur in an interval of 16 days. They've been able to trace back the signal to its home galaxy, but they can't go further than that, for now. Researchers continue hoping that by tracing the exact origin of the bursts, the mystery shall be solved. Number 3. How many exoplanets are there? Some of you may not know or remember what exoplanets are, so before deepening further, let's recap briefly. According to both NASA and the ESA, an exoplanet is by definition a planet outside our own solar system. To date, we're able to map and confirm more than 400 exoplanets. Even if they're part of different systems, they may be similar to our planets. Some are massive, like Jupiter for example, whereas others are rocky or icy, just like ours. But then some of them simply don't have analogues in our solar system. The possibilities are endless, which is why the pursuit of exoplanets is an ongoing process. Therefore, there's no way to tell how many exoplanets are out there. As far as we know, the Milky Way could contain around 100,000 million exoplanets. They're extremely important because among them there may be planets with the right conditions to host life as we know it. That's why it's so important to keep going. To date, more than 4,000 exoplanets have been discovered and are considered confirmed. However, there are thousands of other candidate exoplanet detections out there that require further observations in order to say for sure whether or not the exoplanet is real. Number 2. Space's chicken and egg dilemma. Yes, it looks like scientists have their own causality dilemma. Which came first, the galaxy or the black hole? First of all, we mere mortals have to understand why the two are connected. So the general consensus is that things start off with the galaxy. The reason you can find a black hole is that the gas and dust in it will go into the black hole and feed it, making it grow its mass. However, research from astronomers examining radio frequency pictures that provide data about early galaxies suggest that black holes may have gotten an early start. Back in 2012, an international team of astrophysicists discovered a galaxy with a black hole with a mass that's T1000 times larger than expected, based on typical galaxies. And this, according to the research team, leads them to believe that black holes formed first and then somehow they formed a stellar galaxy around them. Still, according to other scientists, and NASA too, such assumptions can't be taken for certain. Therefore, the question remains one of the greatest puzzles of our universe. Number 1. We don't know our own biology. You made it to the end of the video, and now we're looking at ourselves rather than space itself. But why? What does human biology have to do with space research? Actually, a lot. From roles in the health and nutrition of humans during spaceflight to the questions of life on other worlds, microbiology is fundamental in the exploration of the cosmos. Therefore, a large focus of space research has been focusing on studying our microbial world. The same teams are also studying what makes us differ from alien life. I mean, space exploration has been focusing on looking for other forms of life as we know it. Maybe the reason we still haven't found what we're looking for is because we haven't looked outside the box. But now, microbiology studies are paying off. There's recent evidence that conditions different from the one we know to support microbial life exist elsewhere, not only on Mars but on Saturn's icy moon and Enceladus, whose hydrothermal activity and the production of molecular hydrogen and carbon dioxide may sustain microbial life. So those were 10 things we still don't know about space. Which is your favourite theory? Let me know in the comments down below. Be sure to give this video a like and subscribe to All Time 10s if you haven't done so already for more great videos like the ones that are on screen right now.